The objective of this lesson is to graph log equations. So we're going to introduce the idea of how to graph these. First of all, we want to get the connection to exponential equations as well. So when we look at an exponential equation, its graph will typically, a growth graph will look like this. And when we want to find the log, since it's the inverse of an exponential, it is the reflection over the line y equals x. So reflection over y equals x of the exponential graph. So when we look at the graph, what we'll see then for the log is it will look like this. It will also have an asymptote, but instead of the x-axis being the asymptote, the y-axis or a vertical line will be the asymptote for it. So when we do these, the basic graph of a logarithm is going to look like this. It goes through 1, and this is the asymptote for the basic family of function graph will be x equals 0, the vertical line. So when we do when we look at the equation, the thing that you have to understand is what's inside the logarithm is what becomes the asymptote. So when we have this, our asymptote, you grab from inside, and it becomes the asymptote is x equals the h, the opposite of that number. Whatever makes this equal to 0 in here is our asymptote for our logarithm graph. All right, so let's look at some examples. So when we look at this one here, we look at the inside of the logarithm, we take this, and this means our asymptote is x equals 3. So we want to go here to 3 and create a vertical asymptote. Remember, for logarithms, our asymptotes are vertical. Now we want to get a table, so I'm going to go ahead and look at my graphing calculator for this. So we're going to go to the graphing calculator. Notice I used just base 10 log. There's no base here, so it's base 10. That's our common log. So I'm going to go to our y equals, I'll put in 5 log of parentheses x minus 3. And then our graph will look like this standard graph with it. Notice that it doesn't get past 3. And so our graph will be having an asymptote here and then curving off in this direction. If we go to the table, there's errors before we get to 3 because you can't get 0 in a log. You can't get negatives when you put them into a log. So in here we couldn't put 3 or anything less than 3. But past 3 we get other values. So for x's and y's that I get off of this table, if you look, there's some other values here. And so I'm going to just go ahead and pull off of this 4, gave me 0. I'm going to get some decimals. 6 will give me 2.4, and 10 will give me 4.2. All right, let's go ahead and graph those. So first of all, 4, 0 is right here. 6, 2.4 is right about there. And then 10, 4.2 is up here. So I've got my following the asymptote down this direction in the negative direction. And there's my graph close to the asymptote here and then curving off. And it's getting shallower and shallower, but it keeps going up forever. So when we talk about domain for this, the domain is not all real numbers because I can't get to 3 or past it. So my domain is x has to be greater than 3, greater than the asymptote here. Whereas my range, it goes down to infinity. And even though this is leveling out, it still keeps increasing forever. Eventually it gets to any positive real number. So the range will be all reals. All right, let's try this next one. We're going to go ahead and look on the inside here and get our asymptotes. The asymptote for this one, vertical asymptote, is going to be x equals -5. You take whatever will make this equal to 0 on the inside, which we can have, so that's going to be the stopping point for our graph. So I go here to -5, draw my asymptote. Now I'm going to get a table from my calculator. Notice I use natural log here, and ln stands for natural log. It's log base e. So I'm going to go to my calculator. I'll clear off this one, and I'll put in natural log. So natural log of x plus 5. And then close my natural log. Then I'm going to put a +2. Now this +2 actually does impact the graph by moving it up 2 units, but because of the curving nature of this, it's hard to see that. If you have time, you could explore by take off the +2, compare it to this one, you'll see that it's been shifted up 2 units, but we just see that same behavior though, coming close to the asymptote and then curving away from it. So when we look at the graph, it looks like this. And notice it doesn't show, it looks like it stops there, but it doesn't, because it's going down so steeply, the graphing calculator can't represent that it goes down next to the asymptote. So don't think that this looks like, say, a square root graph where it ends. It keeps going down. If we were to put in tiny numbers just above where our asymptote is, here just above -5, then you would see that it would still have values there, but it never gets to 5. So since it's so steep, the graphing calculator doesn't represent it, but we're going to show it. I'm going to put it on our table. So I got off of the table -4, 2. I get off -2, 3.1. I get off the table 0, 3.6, and then 5, I've got 4.3. So if you look back at your graphing calculator and you go to the second table, you'll look at some of these values. Notice there's errors, and then we start getting values, and those values we're going to go ahead and plot on our graph as part of it. All right, so now I'm going to go plot these. So -4, I'm going to go with 2, so up here 2. -2, I'm going to go with 3.1, about there. 0, about 3.6, a little bit higher. And then 5 up to 4.3. And so my graph goes along the asymptote here, and then it curves off here. Gets shallower, but it still increases. So my domain would be that x has to be greater than -5, and my range would be that y is all real numbers. As it goes down to the asymptote here, and then this one, even though it's become shallow, it still increases until it gets to any number we need it to. So when we do our graphs, you've got to first of all find the asymptote. Whatever makes it 0 on the inside of the log, that's your asymptote. Go to your graphing calculator, come up with a table, and draw your graph.